Okay, hello everybody. Today we are going to do lesson 18.2. We are going to multiply some more polynomial expressions. So yesterday you were always multiplying something by a monomial. So you had like a single term times a single term, or maybe a single term times a trinomial, which just took some distributing. But today we get a little bit more fancy. So for multiplying polynomials, this is one of my favorite things. Okay, you guys want to look at this problem right here. Okay, this is a binomial times a binomial, and a lot of your problems today are going to be that. So I want you to write, if you have a binomial times a binomial, you get to use this super cool rule called FOIL. So write FOIL real big like that. Okay, so this FOIL rule only works for a binomial times a binomial, but when it works, it's pretty cool. In FOIL, the letter F stands for first. The letter O stands for outer. The letter I stands for inner. And the letter L stands for last. First, outer, inner, last. Okay, so here is the deal. I'm going to write that problem that they have up here again. X plus 3 times x minus 7. Here is what I mean by first, outer, inner, last. Basically, you have to make sure everything in this first binomial gets multiplied by everything in this binomial. Okay, so check it out. First term in this set of parentheses and first term in this set of parentheses right here. First times first is x squared. Okay, outer. Okay, outer means, see the outer edges of this, x and negative 7. X times negative 7 is negative 7x. Inner, see the 2 on the inside, 3 times x is 3x. Last means the last term in this set and the last term in this set. Like 3 times negative 7 is negative 21. You just foiled. Now, you do have to simplify. If you get to the end, you should notice that your two middle terms, they're probably going to be like terms. So your x squared stays in x squared, but you should combine like terms. Negative 7x plus 3x should be negative 4x, and then minus 21. So this would be my final, most simplified answer after I FOIL my binomial times a binomial. So let's try that a couple of times. Okay, we're going to skip right down to 4 through 6. Okay, so skip 1 through 3. We don't need to do it extra times. Okay, this is what I need you to notice. See that binomial times binomial, binomial times binomial, binomial times binomial. That is when I need you to see that problem and go, ooh, we can FOIL it. So let's practice FOIL. I'm going to zoom in on 4. Here we go. First, x times x, x squared. Outer, x times negative 3, negative 3x. Inner, negative 2 times x, negative 2x. And last, this is negative 2 times negative 3 is positive 6. Negative times negative, positive. And then look, combine like terms. So final answer is x squared. Combine negative 3x and negative 2x to make negative 5x plus 6. Okay, again, binomial times binomial means FOIL. First, x times x, x squared. Outer, x times 7, 7x. Inner, negative 7 times x, negative 7x. Last, negative 7 times positive 7 is negative 49. Okay, combine like terms. 7x minus 7x is, hey, no more 7x. You're going to have x squared minus 49 because your 7x and your negative 7x canceled out. Okay? Moving on. One more time on the FOIL, and then I think we should have that down. Okay, first, x times x, x squared. Outer, x times 1. I mean, 1x, but let's just x. Inner, 2 times x, 2x. Last, 2 times 1, 2. Combine like terms. X squared stays by itself. This is like 1x plus 2x is 3x plus 2. Okay, now, sometimes you're going to get a little bit extra here and have a binomial times a trinomial. Okay, guys, for this, the best thing I can tell you is it's basically like a gigantic distribution problem. So you've got all this space down here. Okay, I know it's going to take you a second to rewrite. Don't worry about this. That's just confusing. Okay, rewrite it. I need you to have some room. X plus 3 times 2x squared plus 4x plus 8. Okay, here's the deal. Okay, I need everything in this set of parentheses to get multiplied with everything in this set of parentheses. So it's, like I said, giant distribution problem. Pick the thing that has the least, like this only has 2 terms, this has 3. Okay, pick the thing that only has 2 terms and say I'm going to distribute that. So what I mean, okay, and I'm going to even use a different color here to show you. I need you to do this x times everything. So I need to do x times 2x squared. That's 2x to the third. Okay, sorry, my 3 doesn't look very good. Okay, and then I need you to do x times 4x. That would be 8x squared. And then I need you to do x times 8, which is 8x. Okay, back it up. I'm sorry. X times 4x was 4x squared, guys. I got carried away. I looked at my 8. Sorry if you were thinking I was crazy. I was. Fixed. Good. Moving on. Now, you have to take that 3 and multiply that 3 times everything. 3 times 2x squared, 6x squared. 3 times 4x, 12x. 3 times 8, 24. Now, combine like terms. 2x to the third. Any other x to the thirds? Nope. 2x to the third. Okay, x squared and x squared. So 4x squared plus 6x squared, 10x squared. Okay, 8x plus 12x, 20x. And then your 24 hangs out at the end by itself. Final answer. It's just giant distribution problems, but I like multiplication, so I don't mind. Okay, let's do it again. 8. One more time on the giant distribution problem. Okay, so x plus 2 times 6x squared plus 4x plus 5. There we go. I'm just recopying it for more room. Okay, so I'm going to take this one, that's the shorter one, because then I only have to do x times everything and 2 times everything. I need to do everything times x. So x times 6x squared, 6x to the third. X times 4x is 4x squared. X times 5 is 5x. Okay, now go back through and do the 2 times everything. 2 times 6x squared is 12x squared. 2 times 4x is 8x. 2 times 5 is 10. Okay, combine like terms. 6x to the third is the only one. 6x to the third stays by itself. Okay, x squared, 4x squared, plus 12x squared should be 16x squared. 5x plus 8x, 13x, and then you got a plus 10 all by itself. Okay, moving on to the back side. We need to do a word problem. Okay, so real quick for your word problem, let's put up here, okay, modeling with polynomial multiplication. Modeling with polynomial multiplication. Okay, and we are going to do page 674, your turn, and it's going to be number 10. So give everybody a second, get to page 674, and everybody find number 10, and then come back to me. Okay, so number 10 is a landscaping problem here. Okay, it says a landscape architect is designing a rectangular garden in a local park, and the garden will be 20 feet long and 15 feet wide. Okay, I'm going to go ahead right there as soon as they tell me that. Okay, I'm drawing. Here, let me get my paper situated. There we go. Okay, rectangular garden. Draw it. Rectangular garden. Okay, it's going to be 20 feet long, 15 feet wide. Good? Rectangle. Okay, now here's the deal. Okay, the architect wants to put a walkway with a uniform width all the way around the garden. So, walkway around the garden. And you're trying to make it like this, so kind of like a sidewalk, you know, around the outside of the garden. Uniform width, so same width all the way around. Okay, and then it says, what will the area of the garden, including the walkway, be? Okay, so here's the deal. Did they tell you how wide the walkway was? No. So here's what you do with that. Okay, you're like, well, they didn't tell me how wide the walkway was. All right, so here, I'm going to put this in here. Then this width from like here to here, right? It's X feet long. I have no idea how long it is. But I do know that it is uniform. So if this walkway extends X feet on this side, it also extends X feet on this side, right? So that means from here to here, this part's 20, and the walkway adds 20 plus 2x. On this one, again, I know that the walkway extends X feet in this direction and X feet in this direction because it's the same on all sides. So this side is 15 feet plus 2x. Okay? And they want to know, what will the area of the garden be including the walkway? Well, how do we find area? We multiply. So you should be doing 20 plus 2x times 15 plus 2x, which means that's a binomial times a binomial, which means you get to use FOIL. First, 20 times 15 is 300. Outer, 20 times 2x is 40x. Inner, 2x times 15 is 30x. And last, 2x times 2x is 4x squared. Now, that is not in standard form, and it is not simplified. So, first of all, 4x squared should go first. Second of all, 40x and 30x should get combined and be 70x. And then your 300 should go at the end. The area of the garden plus the walkway is 4x squared plus 70x plus 300. So, multiplying lesson, okay? If you see a binomial times a binomial like you did here, or like you did here, FOIL. If you see something times a longer polynomial, you're just going to have to do a lot of distributing and carefully combine your like terms. Homework. You guys should be doing page 674 to 675, 2 through 22 even. So make sure you got 18-2 ready to go. Good luck with multiplying polynomials.